Welcome to this video about Strands Agents. In this video, I'm going to show you how to host a large language model on your PC or laptop or whatever hardware you are going to use and run Strands Agents. Strands supports multiple providers. In previous videos, I have been using Amazon Bedrock, but you can also use it with Anthropic, Light LLM, and a bunch of others. One option is also to use Ollama. And Ollama allows you to run large language models on your own hardware. The integration of the local model just happens through the so-called Ollama model provider that's shown here on the right side of this slide. And all you do is you define a so-called Llama host that points to your local host on this port 11434. Once you run the Ollama software on your PC or laptop, you can use that service to run a local large language model. In this case, the code points to the Llama 3.2 model. So we are going to run these kind of models on local hardware. It has to be noted, though, it's going to be slow. So I'm going to make a couple of cuts here to keep the waiting in this video short. For those that want to follow along with this video, the code and the notebook is on this GitHub repository, which you can either reach through this QR code or the link that is here on this slide. Now, without further ado, let's get to the notebook. So if you go to the GitHub page and you download the zip file or use Git to clone the repository, you will get a bunch of notebooks. Today, we are going to focus on the number 4 notebook, Local Models Ollama. And once you open this, in this case, using Visual Studio Code or any other IDE that you prefer, then you will get this notebook here, which outlines you some of the advantages and disadvantages of running your large language model locally. To run Ollama on your own laptop, you need to download the installer for your operating system. I'm demonstrating this here on Windows, but for those that use Linux or Mac OS, it's pretty much the same. You download the installer from the page, which comes from this page here, and you click on download for Windows or Linux or Mac OS, and then you run through the installer. And the important piece here is at the end, you will have a running service in the bottom of your taskbar, which is here. And that shows you that you have installed this piece of software, which encapsulates the large language models. Of course, you can also do this through the command line. On macOS, you can use the brew installer, or you can use Linux command line tools to install it. Once you've done that, and after you've downloaded it, it's a fairly substantial download of about 1 gigabyte, then you will have the software installed on your computer. We need 2 pieces of libraries and packages installed as well. The first one is the usual Strands Agents installation that we have been also seeing with some of the other Strands Agents videos that I've presented. And then you also need this Strands Agents Ollama provider here, which also needs to be installed. So once you've done that, that will allow you to use Ollama. In the notebook, I have provided you with a little check that runs through the different pieces of Ollama installation and will automatically check if your installation is okay. You can skip that, but in general, if you have a green tick mark here at the end, you should be good to go. The Ollama software itself doesn't contain the models. The models are something that is separately installed, and this needs also some downloading. If you need to download them, you should have a good internet connection because some of these models are fairly large. In my case, I've already done that. And so I'm getting green tick marks here immediately, but it could be that you need a couple of minutes to download these. Depending on the speed of your internet, this can take up to 20 minutes if you have a slower internet connection, because again, the models are fairly large and need some downloading. The next step in the notebook is that you can check if the models are installed. In my case here, I have Mini, I have Mistral, and I have Llama 3.2. As you can see here, the size of these models is quite large. So we have about 2.2 gigabytes for Mini. We have Mistral and we have Llama with 4 and 2 gigabytes. So those are fairly large models. And it's important that these model sizes are compressed. If we run them, they need to be uncompressed. So they take about twice the RAM that is given here in size. That's a rough estimate, but usually that's okay. You can already see that for Mistral, for example, if you have a very small laptop that only has 8 gigabytes of RAM, you are not going to be able to run this. Since I know that most people have about 16 gigabytes of RAM, I decided with 4 gigabytes being the largest model here, we should be good to go. Now, how do you create an agent using the Strands framework? And in previous videos, we have usually taken the approach that we use Bedrock. In Bedrock, we basically define a Bedrock model, and the Bedrock model would need just a model ID. In the case of the Ollama model provider, we need to provide a host. That's the URL that you're seeing here. And then there's the model ID, which just identifies which model we want to load. In this case, we are loading with a Llama 3.2 model, which has been installed and shown on one of the previous outputs. So with this, we should be good to go. And we've defined our first agent here, just using the normal agent constructor that we've seen in some of the previous videos as well, with a system prompt that says you're a helpful assistant running locally, be concise and frank. So nothing new except this piece here about the Ollama model where we provide a host and a model ID. Let's have a first conversation. And the first conversation is, give me one sentence with advantages of running LLMs locally. The Llama agent will try to answer this. It doesn't have any tools like the Google tool that I have provided you in one of the videos that I'm marking here. What we are going to do is we are going to just interact with the large language model in this video. We can see now it's 53 seconds it took, and the sentence that we generated was running large language models, LLMs, locally can provide faster inference speeds. I'm not so sure about that. Reduce dependence on the internet connectivity, that's true, and improve data privacy without sacrificing the accuracy and functionality of these powerful models. Now, I'm not fully in agreement with the sentence, but let's keep it. We note down that it took about 53 seconds to generate this answer. If you recall, in some of the previous videos, I've asked the models to generate some extensive text, and that took less time than it took us here. But we have been able to now interact for the first time with a large language model on our computer through an agent. Now, let's also look at how different models that Ollama provides run. And we generate an agent here that has different models, and we run those and try to get the same answer. It takes about 6 to 7 minutes on this computer, which is a fairly large cloud instance. Each of the models using this prompt here, write a Python Hello World program. So it's a fairly short answer that should come out of this, but it's still going to have to do a lot of work in the background to generate the answer. While this is going on, I'm going to go back to the Bedrock page, and I'm going to ask it also write a Hello World program. This is not really an apples to apples comparison because I'm using a rather powerful model here to generate the answer. The responses are in from our 3 models. As you can see, it took a while for each one of these to write a simple Python Hello World program. In the first case, we had the Llama 3.2 model. It basically provided us with an answer like you would expect it about a Hello World program in Python. This took 203 seconds. On this machine, which has 64 gigabytes of RAM, 16 cores, so it's more than you would have it on a laptop or anything like that. It still takes 200 or 127 seconds to come up with a relatively simple answer that contains 250 characters. The Phi Mini was even shorter, it took 100 seconds for 39 characters. As you can see, it's not really performant. If you look at what we had with Claude 3.7 in Bedrock, that took us about 4 seconds or 4,068 milliseconds. And the answer has more text. This took 4 seconds versus here 200 and 127 and so on seconds. So you can see that the time it takes for the responses to come in is significantly higher than what you would have on a cloud instance. And that's because in the cloud, we have specialized hardware that runs these models and is able to provide you answers in a much faster and quicker way. Another argument that is often cited with the use of local models is that it's more cost efficient. It's true that with LLMs, you pay for the use of the LLM. So for every token that comes out of the large language model, you have to pay for it. For small models, this can cost you about 15 cents for a million tokens. If you want to look this up, then you can go to the, for example, Bedrock pricing page, but you can also use the pricing of any of the other cloud providers of Anthropic and so on. So this is the pricing page. Here you can see, for example, Claude Opus, which is the most expensive model. It has 15 cents for 1,000 tokens. Then you have other models that are significantly cheaper, like Claude 3.7 is only 0.003 for 1,000 tokens. And then there are models like Haiku 3 that are fractions of cents for 1,000 tokens or even a million. So as you can see, the price is computed per token. And when you consider this, like how much is a million tokens? A million tokens is a lot of text. It's about 750,000 words, which is about 2,500 pages or 10 PhD dissertations. Or you can say it like this: the entire works of Shakespeare fit into 750,000 words. That's a lot of text for these 15 cents. Now, when you run your model locally, you can create as many tokens as you want, and all tokens cost $0, but you pay for the hardware, which costs money, the power to run the hardware, and potentially also for software licenses that you need, for example, to run these models on GPUs. So let's say you spend $100 for all of this, which is unlikely because, for example, GPUs are very costly. Then you can generate 666 million tokens with those $100. And it's unlikely that you're going to surpass this limit with your $100 budget. From a cost perspective, it's almost never a good business case to run a model locally on your own hardware. There may be other reasons why you want to do it, but cost is not one of them. I still provided this video to give you a view on how you can run an agent with a local model. But nevertheless, I have to state here a certain facts regarding performance and also the price. With this, I'd like to thank you for your attention. If you like this video, leave a like. If you have a comment or don't like my discussion, then also leave a comment. If you have questions as well, leave a comment. And I would be happy if you would subscribe to my channel. Thank you for your visit on this channel and viewing this video.